Hello everyone, welcome to Try Right, the new era of learning. Myself Rafiq. Today we're discussing about natural language processing, language models. Okay, so what is a language model? We know that language model is a probabilistic model that predicts the likelihood a sequence of words, right? It helps machine understand and generate human language by assigning probability to the sequence of words and predicting the next word in the sentence. Okay, so we all know about the NLP. NLP is a subfield of artificial intelligence that focus on enabling machines to understand, the interpreted, and generate and response or human languages, right? To the humans. One of the most core concept of NLP is a language model, right? So what is the purpose of language model in NLP, right? So we use that purpose for text prediction, text generation, speech recognition, and machine translation, and for sentiment analysis, right? So in it we have a language models or a fundamental components of natural languages processing. So and conventionally linguistic that are designed to the understand, generate, and predict human languages. Like those models analysis the structure and uses of languages to perform tasks such as machine translations, text generations, and sentiment analysis. Right. So the article explores a large model in depth. Okay. Statical language model is based on the probability and statics. Okay, so in this we have unigram, bigram, like that we have most concepts. So what are the language models in NLP? A language model in natural language processing is a statistical or machine learning model, right? That uses to predict the next word in a sequence, the given previous word language. Language models play a crucial role in various NLP tasks such as machine translation, speech recognition, text generation, and sentiment analysis, right? We already discussed about that speech recognition, text generation, and about sentiment analysis and text analysis, right? So, the analysis and the understand the structure and the use of the human languages so enabling machines to process and generate text that is contextually approximate and coherent, right? Here we discuss about models can be broadly categorized into two types, right? In this LM models, it has, right? So pure static models and neural models, right? In pure static model is for a basis. So basis of traditional language model, those methods rarely on the statical properties of language to predict the next word in a sentence. It gives the previous word given by the previous word. That includes n-grams, exponential models and skip-gram models. Okay. So, what about n-gram? An n-gram is a sequence of an n items of for the a sample of text or speech, such as phonemes, syllabus, letter, words, or base pairs. N-grams model uses the frequency of the sentence in the training. So, we know that, for example, this definition is too long. So, by reading this, you get bored. So, I explain in simple terms what is done by the n-gram. Okay. So, Ngram is a model of statical. Okay, it is a model of statical. Okay, so from the statical model, the Ngram designs defines its contiguous sequence of n order items. Like if according to your n number, it has unigram, bigram, trigram. Right? Unigram for one word, like the cat on, like that. Anything dog bigram for 2 word sentence, we take 2 grams, and 3 grams for 3 gram, like 3 word sentence. For the 1 gram, we take only one word, like cat. For the bigram, we take the cat. For the 3 gram, we take the cat is like that. We take about the according to the grams how it works. It estimates the probability of the words based on the previous. Okay, so it has a simple to implement work well on small data sets, right? So it has some pros and cons. So we know the pros about works well in smaller data set and simple to implement. About the cons, limited context. Okay, We have the many possible words combination not seen in training. Okay. So this is the sentence like if you take N1, this is a sentence, right? We divide the one unigram as this is one, is one sentence, A is 1 gram, and sentence is 1 gram. If you take you take 2 gram by gram, it is this is a sentence like divide. This is one sentence, easier one sentence, a sentence like by gram. In 3 gram, it takes three sentence. This is a an easier sentence like that. It takes a and like that it works. Now comes into the explanation model. Explanation models such as maximum entropy model are more flexible and powerful than n-gram model, right? They predict the probability of a vote based on the wide range on futures, including not only the previous vote, but also other contextual information. Those model assign weight to different futures and combine them using an explanation functions to estimate the probabilities, right? We have the maximum entropy model like okay max ent we call those. So in simple terms, we define it as so those models calculate the probability using explanation function, right? And are based on the maximum entropy principles, which assumes nothing beyond the known data for okay. So it considers future functions, learned ways, normalizing contents, and it allows incorporation of many types, okay, like linguistic futures, okay, so more flexible and powerful than n-gram. So, skip-gram model. Like skip-gram model is one of the type of statistical method used primarily in word embedding techniques that predict the context word, surrounding words given a target word within a center or certain windows a size of gram. Like we has a word to vec and skip-gram. Like we can instead of we can say definition a type of modalities often used in word to vec designed to predict surrounding words context give a targeted word like for example we can see if you take the cat sit on the mat, the cat sit on the mat for sentence targeted the word like sit context word meaning the cat on the depending on the window size, okay. So we take input as one, the cat sit on the mat, it takes projection. So it divides the sentence like one plus one. Look, the cat sit on the mat, like the cat sit on mat, like on the mat, like divides the sentence by unnecessary sentence, okay. So it tries to maximize the probability of content vote given by the center vote, okay. So if the in this the center vote is mat, right? The cat sit on the mat. So set is the cat sit on the mat, right? Chat is a middle word. So it removes the content and said the cat on the mat. Like that, it depends on the sentence, right? So use it to learn embedding this vector representation of words where semantics similar words are too close to the vector space, okay? For capturing semantic relationships, and we say that work well on large data sets, okay? So it limitations maybe how need large data training, okay? And now comes to the neural models. Neural models have revolutionized the field of NLP, leveraging deep learning techniques to create a more uh, sophisticated and accurate language models, right? So we all know that about the recurrent neural networks, transfer-based models, and large language models (LLMs), right? We all know about the recurrent neural networks, right? So we a recurrent neural network is a type of neural network, sequential data, making them well suited for language modeling, right? So we have LSTM, long short-term memories, and we have GRU, gate recurrent units, right? Further, in experience improver, design the sequence data such as text or speech, maintain a memory of previous input using loops in the network, like it solves the problem like capturing the word dependency in sequence, right? Subject, verb, argument, like right? So it is the recurrent we use, it is the model. So we can see it includes the loop, like whenever we unroll the loop, it opens the limitations of the, depends on the sentence. Okay, we have in one to one, one to many, many to one, many to many, like the types. So transformer based models, like the transformer model both introduced the Vasavi in 2017, Vaswani. ETL. So sorry about a little pronunciation mistakes. So remove this definition, this context. So it is for self-attention mechanism, enrolled decoder structure, and positional encoding, right? So mechanism use its self-attention to weight the importance of the different words in the sentence regarding less of the positions, right? And we can say that key involvement in that is so introduce the paper attention is all you needed in 2017. We all know that. So it example for translator transformer based model is so BERT means it is one type of language model. We said bidirectional encoder represented from transformers, good understanding at context, GPT, generative pre translate trained transformer good at generating fluent text for use. Another model like T5 RO robot Excel net like that we use in it. So it's a we use a translation explain transformer learning pre-training and fine tuning like we use this it is a beginner guide to transform based NLP models, right? So now comes to the LLM models. LLM models have the pushed in the boundary of the possible NLP. Those models are categorized by the vast side of the often comparing billions of the parameters. Like the training large models involves the feeding the vast amount of the text data into optimizing. Like it uses a pre-training method for large followed supervised tasks. So we can say that instead of we can say that also defines those very large scale transformer based models training on the massive data sets like example GPT-3 GPT-4 or chat GPT like that we have LLAMA we can say the capability for text generations translations summarizations and reasons and answering the questions. It has the LLM as the main strength has a high fluent and a human like response and highly fluent response like directly communicating like an human intelligent, right? So can perform the zero shot and the few shot learning. So it has approaches like in the NLP algorithm and the models are used in supervised training. The required labeled learning data and only works with specific tasks, right? Where it comes to the approaches in LLM, large model LLM are designed and trained on with unsupervised data. Like we know the supervised and unsupervised learning. So supervised means it deals with labeled data, unsupervised it deals with unlabeled data, right? So it approaches the fine tuning LLM to perform the specific task without using additional training, right? So its scope is nothing but the notion encompasses algorithm and the models that left the machine interpret, translate, summarize, and analyze the text inputs. AI products uses the component specifically to comprehend the generate human-like content, right? So in training data, we have the labeled data fit with supervised learning. So it has supervised and unsupervised training, understanding semantic and context and syntax. Okay. So popular language models in NLP, we all know that bidirectional encoder represented for the transformer B or T and GPT is nothing but generative pre-trained transformer 3. In this, we can use GPT-4 also. So it is a variant of GPT-3. So T5 is nothing but text-to-text transformer and both to web vector and ELM with the embedding from the language modeling, so transformer Excel, XLNet, uh, robustly optimized BERT approaches means robustly optimized bidirectional encoder represented from translate transformers and albeit nothing but light we called as a light bidirectional encoder represented from the transformers right? Turning NLG. So these are the models view. So finally, conclusion. To conclusion, in the conclusion, language models have evolved significantly from the simple statistical methods, right, to complex the neural network. Okay, so enabling a sophisticated understanding on the generation of human languages as those models continues to advance, they hold a potential to revolutionize many aspects of technologies and communications, whether through improving such result generating human like text and enhancing the virtual assistants, language models, or the forefront of the AI revolution, right? We all mix with the it's a mixed combination of the AI version we use in the artificial intelligence, right? So I hope you all are understand about the concept of natural language processing in language models. So thank you all.